Now, good morning students, how are you all? Now, yesterday we have seen differentiation. Today again I am starting differentiation part 3. Today we will see second derivative. Today we will see anyhow second derivative. Now let me start the second derivative. That is second derivative. So what is second derivative? Now see, let y equal to f of x. Let y equal to f of x is a real valued function. A real valued function defined on domain, defined on its domain. Then we have seen already first derivative, then its first derivative, its second derivative. I am starting directly second derivative. Before doing second derivative, we must know about first derivative. So that is dy by dx, that is rate of change of y. That is, we say y1, we say y dash. We can write like this, that's already explained you, f dash of x. Now we are again differentiating this d by dx of, that is dy by dx. We are differentiating dy by dx with respect to x again. So that is equal to y2 we can write, or otherwise we can present y2 dash, that is equal to f2 dash of x. Now what is this? That is d square y by dx square, that is equal to f2 dash of x. Means we are differentiating second time with respect to x as a second time, that is denoted by d square y by dx square. If you write dy square dx square, this is no meaning of it. That's try to understand. Now what I told you, we are differentiating second time y with respect to x as a second time. Okay, fine. Now so let us take some example for this second derivative. Now I am taking question. If the question is given x is equal to tan 1 upon a into log y, show that the question is given, show that is 1 plus x square into d square y by dx square, and then plus 2x minus a into dy by dx equal to what is the 0. Okay, fine. Now anyhow, see, the question is x is equal to. So what I am doing, slight changes I am doing, that is 1 upon a into log y, that is given. Now I am changing this question in terms of y, that is y equal to something I am bringing. Now see how I am doing this question. That is, I am taking 1 upon a into log y, that is equal to tan inverse x. Okay, fine. Now this implies log y equal to a tan inverse, log y equal to a tan inverse x. This implies y equal to e power a tan. It is quite difficult to do differentiation. Now find dy by dx. Now dy by dx, that is equal to, what is dy by dx? Ex. What is ex differentiation? Ex into differentiation of a tan inverse, a upon 1 plus x square. Am I correct? One thing keep in your mind, whenever you do second derivative, try to avoid quotient rule. If you take this 1 plus x square to the side, so try to use product rule. That's what I am saying. More than 99% you can get your proper answer very immediately. Tan inverse x. Now use here product rule. So 1 plus x square into d square y by first derivative, this is dy by dx. Again we are differentiating, plus dy by dx, keep constant. 1 plus x square differentiation is 2x into dy by dx, that is equal to, already a is a constant, e power ex differentiation is ex only, into differentiation of this a upon 1 plus x square. Am I correct? Again take it cross multiplication, 1 plus x square. So 1 plus x square whole square into d square y by dx square. So this is one of the result. As per this question, what we can do, that's I will tell you. So that is plus 2x into dy by dx, that is 2x into this 1 plus x square we are taking. This is one result, that is into dy by dx. Now that is equal to a square into y. Means I am proving there are two results here, 1 plus x square whole square, d square y by dx square, or plus 2x into 1 plus x square into dy by dx e minus a square y equal to 0. This also we can prove it. Now as per question what they are asking, now you have to change certain change here. See, now see, we have proved what we have proved, 1 plus x square into dy by dx. So what I am saying, as per given proof we have to move the question. A into, instead of this what we can write, a into y, Am I correct? We can write a into y. This is a given term. So I have replaced that as in terms of this is y. Now start to do differentiation product rule. 1 plus x square into d square y by dx square and then plus 2x into dy by dx. So that is equal to a into dy by dx. Now as per proof I am saying. So this implies what we are getting. So 1 plus x square into d square y by dx square. Now plus 2x minus a into dy by dx equal to 0. See, this is as per given proof. So that means they can ask two questions. Either the question is given this, show that this. Either this question is this, show that this. So anyhow, both way you can easily solve it. Now what I am saying here, what is given, what do you want to prove? So keep this point in your mind, then start do. So if you want to prove, you can change here little bit. If you want to prove this, again you have to do like this. Clear to you everybody? Okay, now let us see another example. Another example I am taking. I hope so everybody clear this is second derivative. How to do second derivative. Now let us see another one, another example I am taking. Anyhow, second derivative based also one question will come in our board exam. So now another question I am taking. Suppose if they have given x is equal to under root of a power sine inverse t and y equal to under root of a power cos inverse t. Now find d square y by dx square. Okay, fine. Now see, x is this, y is this. Before finding this d square y by dx square, we need dy by dx. Very easy way I am doing here, x and y. I have seen a power sine inverse, a power cos inverse. That's why I am doing multiplication here. It becomes a power sine inverse t into under root of a power cos inverse t. The base is same. We can add the power a power sine inverse t or plus cos inverse t. Am I correct? So what is the result? Sine inverse plus cos inverse becomes, that is pi by 2. Am I correct? You have seen in inverse trigonometry this one, pi by 2. Now start do differentiation product rule, of course. X into dy by dx plus y into differentiation of x is 1. That is equal to, it becomes what is it? 0. So this implies dy by dx equal to what we will get it? Minus y by x. Am I correct? Now they are asking second derivative, d square y by dx square. We are differentiating dy by dx with respect to once again. That is equal to, of course, question 2. Now x square, keep x as a constant, minus keep it outside. Now differentiation of y is dy by dx minus y keep constant, x ka differentiation is 1. Now finally what we are getting, so that is d square y by dx square, that is equal to 1, x will be cancelled, x into dy by dx. Otherwise this upon this karangi, that is minus, this minus minus a plus y upon x square. So if you want to bring this side, everything bring it to that side. So this implies, finally we will get the answer. This implies d square y by dx square and then plus x into dy by dx plus x into dy by dx or plus minus y by x square equal to 0. So they can ask like this also, prove that something. Okay, fine. Now anyhow, I am taking another one more question, question number 3. This is for second derivative only. Suppose y equal to, if y equal to sine inverse x upon under root of 1 minus x square, then prove that the result is 1 minus x square into d square y by dx square and then minus 3x into dy by dx and then minus y equal to 0. Now let us see, question is given this. So now what he told you, before doing this question, you take it this side. So y equal to what is given here, sine inverse x upon under root of 1 minus x square. So I told you try to do product rule. So I am taking 1 minus x square this side equal to sine inverse x. Now start do differentiation. Under root of 1 minus x square is a constant. Y differentiation is dy by dx. So plus y I am keeping constant. This is minus 2x upon under root of twice of under root of. So that is root x differentiation. Root x is 1 upon 2 root x into differentiation of inside, that is minus 2x. Am I correct? So that is equal to, you know, sine inverse x differentiation 1 upon under root of 1 minus x square. Again take it across multiplication. So what we will get it? 1 minus x square into dy by dx minus 2x, that is 2 will be cancelled. So we are getting minus xy, that is equal to 1. Am I correct? Now again I am going to do second derivative. So let us see second derivative once again. So what we have done here, y equal to sine inverse x upon under root of 1 minus x square. I have taken this side, so 1 minus x square into y equal to sine inverse x. Now I am using product rule, so that is equal to sine inverse x differentiation. Now once again I am going to do second derivative. So 1 minus x square I am keeping constant into d square y by dx square, and then dy by dx constant. This differentiation is minus 2x into dy by dx. Now again here product rule, x constant dy by dx, and then plus y constant x differentiation 1 equal to 1 differentiation is 0. Now if I open this 1 minus x square into d square y by dx square, so this is 1 time, this is 2 times, so minus 3x into dy by dx, and then minus that is y equal to 0. So I hope so this is, you need your result, I think see this one. Am I correct? 1 plus 1 minus x square into d square y by. So automatically you will get a result. But before doing second derivative, that's keep in your mind, try to avoid quotient rule. You take it this side RHS so that you can use multiplication rule. That is a product rule. That is easy to prove this question. Clear? Clear to you? Now one more example, let us start. Now I am making another example of this second derivative. Now this is another example I am taking. If y equal to x log, this is one of the most important question, complicated question, so you should know how to do this one. So that is, you have to prove that x cube into d square y by dx square equal to x into dy by dx minus y. This is one of the most important question and repeated one. Okay, fine. Now let us start. Okay. So we have to start, otherwise if you want to take this y is this side, that is up to your choice. So if I am taking this y is this side, y by x is equal to log, we are getting x upon a plus bx. Okay, fine, this is equation number 1. Now start do differentiation. Of course this is quotient rule, x square. Now x is constant, y differentiation dy by dx. And then minus y is constant, x differentiation 1, log x 1 upon x, x upon a plus bx. Am I correct? Log x differentiation is 1 upon x. Into differentiation of this one, of course quotient rule, a plus bx ka whole square. Now keep denominator as a constant, numerator differentiation is 1, minus numerator constant, denominator differentiation is b, a is 0, bx is x is 1, b I am getting. Now that is equal to c, this one term will be cancelled. Now if I take, I am taking this 1x will be cancelled. Now we are getting x into dy by dx and then minus y, that is equal to, I am taking this x whole upon x keep it here. Now dx cancelled, so a upon we are getting a plus bx. Am I correct? If you don't know, you can take this x also, that side, x into dy by dx minus y, that is equal to ax upon a plus bx. Anybody doubt up to this? So that is equation number 2 I am taking. Okay, fine. Now start do second derivative. Second derivative they have given. Now it becomes x. I keep it d square y by dx square, and then plus if I keep this one dy by dx, x differentiation is 1 minus y differentiation is dy by dx. Now again here quotient rule, so that becomes a plus bx ka whole square. Am I correct? Now this I am keeping a plus bx as a constant. Numerator differentiation is a, minus ax I am keeping constant, denominator differentiation b, already I told you how we are getting this one. Now it will be cancelled. Am I correct? See, confidently do it, definitely you will get answer. Now, so finally what we are getting, so that is x into d square y by dx square, that is equal to this side, see, axb, this is axb will be cancelled. So finally we have here a square upon a plus bx ka whole square. Am I correct? So now what, as per proof, what you need here? X cube. Now we have here x. So I am multiplying both sides by x square. So x cube into d square y by dx square, that is equal to a square x square upon a plus. Why I am doing as per proof? We need x cube left side. That's why I multiplied both sides by x square. Now this is, anyhow I should bring the result dx square, that is equal to, I can write this becomes ax upon a plus bx ka whole square. Am I correct? Now see your result number 2. Ax upon a plus bx can be written as, that is x into dy by dx minus y ka whole square. That means we are getting x cube into d square y by dx square equal to x into dy by dx or minus y ka whole square. Now see, this you need the proof, easily you will get. Don't get you require the result, you see it and then start do, you will get definitely result. So you take it more questions and do practice. This is a second derivative. So second derivative, you keep one thing in your mind. First derivative, do it. If any term, any function in denominator, take that denominator to left hand side, start do, that is product rule. Easily you will get answer. Thank you, students.